This lesson is over graphing logarithmic functions. Recall, log base a of x equals y means a raised to the power of y equals x. Let's look at an example. Example 1. Graph f of x equals log base 5 of x. Currently, this is written in function notation, but we need to rewrite it with the letter y. When we do that, we now have y equals log base 5 of x. From here, we see the x and y variables, but now what we need to do is change it from log notation into exponent notation. So to do that, we look at the base, the sunken down number, and that now becomes the base. The y is now the exponent. So now our statement is 5 raised to the power of y equals x. Since we now see the equation, we're now ready to do a t-chart. Now usually we choose values for x, but this time, looking at the function, notice y is inside the function. It's with the multiplication, the exponent, the addition. It's where the action is taking place, which means we will choose our y values in this case. We will try a few positives, 0, and negatives to help us get an accurate view of the graph. So we're trying 2, 1, 0, -1, and -2. From here, we plug the values in. So 5 to the second power, well, that gives us 25. 5 to the first power is 5. 5 to the 0 power is 1. 5 to the negative first power, well, remember, a negative exponent means reciprocal. So 1 over 5 to the first, which is 1/5. And now we have 5 raised to the negative second power. Again, the negative exponent means reciprocal. So 1 over 5 squared, which gives us 1 over 25. Now that our t-chart's complete, we're ready to graph. Take a moment to prepare your xy axis and plot these points. Hopefully your graph looks something similar to mine. Now, looking at the graph, let's answer a few questions, such as, is this a function? Well, it passes the vertical line test, so yes. Is there a y-intercept? In this case, there is none. Is there an x-intercept? Yes. Notice the graph does cross the x-axis at 1, 0. The domain? Well, domain means how far left and how far right the graph goes. Notice the graph does not go all the way to the left. It appears to get really microscopically close to 0, but it never actually gets there. So in this case, our domain will be parentheses 0, infinity, close parentheses. For range means how far down and how far up the graph goes. Notice it goes down, we have an arrow, and as we go up, we also have an arrow. Therefore, the range is negative infinity to positive infinity. Is the graph continuous or discontinuous? Notice there's no gaps or breaks, so this is continuous. Do you see any vertical asymptotes? There is one. This time it happens to be at x equals 0. Do you see any horizontal asymptotes? There are none. And then last, as you read the graph from left to right, would you say this is increasing or decreasing? Well, this is increasing. For any exponential function f of x equals a to the x, its inverse is called a logarithmic function base a. The graph of the inverse can be obtained by reflecting y equals a to the x across the y equals x line to obtain x equals a to the y. Remember, to find inverses, you simply switch the x and the y. The equation x equals a to the y is equivalent to y equals log base a of x, according to the log definition. The inverse of f of x equals a to the x is the notation f inverse x equals log base a of x. Let's look a little closer at this relationship. Let's look at the function f of x equals 2 to the x. Now this is currently function notation, but I want to look at it as an equation. So I remove f of x and write it now as y equals 2 to the x. I want to prepare a t-chart because I want to graph and see what this looks like. Now x is our exponent, and so I want to choose some positive values for x, 0, and negative. So I choose 2, 1, 0, -1, and -2. Take a moment now to plug these into the exponent and see what you find for the corresponding y value. Hopefully your t-chart is 2, 4, 1, 2, 0, 1, -1, 1/2, -2, 1/4. Now that we have the completed t-chart, let's graph and see what this looks like. Take a moment now to prepare your xy axis and plot these points. Hopefully your graph looks something similar to mine. Now that we have the graph, we're going to answer some questions and look at some characteristics, such as, can we identify the domain? Well, yes, we identify the domain from looking left to right, and we see the domain will be -infinity to +infinity. Next, we look at the range. The range goes from parentheses 0, infinity. The x-intercept. Turns out the graph never crosses the x-axis, so there is none. For the y-intercept, we see it crosses at 0, 1. For a horizontal asymptote, it appears at y equals 0. In vertical asymptote, well, there is none. Now, what we're going to do is look at the inverse. The inverse function is written as f inverse equals log base 2 of x. Now that's in function notation. I could write it as an equation, which would simply be y equals log base 2 of x, or based on the definition of log, I could rewrite it as an exponent, which would be 2 to the y equals x. Again, we are going to create a t-chart, and looking at the exponential form of 2 raised to the y power equals x, let's choose our values in our t-chart, but this time it will be our y values. So again, I want some positive, 0, and negative. 2, 1, 0, -1, and -2. Please take a few moments to plug that into the exponent function and see what you find for the corresponding x value. Hopefully your ordered pairs are 4, 2, 2, 1, 1, 0, 1/2, -1, and 1/4, -2. Now let's plot these points on the graph. Take a moment now to do so. Hopefully your graph looks something similar to mine. Now we are going to answer some questions. Again, we're going to be looking at the domain. In this case, how far left and how far right. Well, notice the domain only goes from 0 to infinity, and we do not include 0, so it must have a parenthesis. Next, we look at the range. The range goes from all the way to the bottom, the lowest, up to the highest, so it is negative infinity to positive infinity. The x-intercept, notice the graph does cross the x-axis at 1, 0. The y-intercept, notice the graph does not cross the y-axis, so there is none. As for the horizontal asymptote, there does not happen to be one, so there is none. But a vertical asymptote? Absolutely. There's one at x equals 0. Now notice the definition between the function and its inverse is a reflection across the line y equals x. Well, if you lightly draw y equals x, you will see it does create a mirror image or a reflection across that line. Now remember, there's a unique relationship between inverses. Whenever you're finding an inverse, you switch your x and your y values. Well, look at your t-charts. On the left, we have it written as 2, 4, but for the inverse, the order is switched. It's now 4, 2, and it worked that way with all of the ordered pairs. Also, look at your domain. Your domain became your range of the inverse, and your range became your domain. They switched because the characteristics of x now became the characteristics of y. Also, look at your intercepts. They too switched. And your asymptotes, they too switched. All because you switch the x and the y, which means all characteristics change. Let's look at an example. Example 2, graph the function g of x equals log base 3 of x. Well, first, we want to rewrite this with the letter y. When we do, we now have y equals log base 3 of x. Now, when trying to graph log functions, you want to make sure log is isolated. In this case, it already is. So, we're now ready to rewrite it as an exponent. Because this is log base 3, that means when we rewrite it, it will be 3 raised to the power of y equals x. Now we're ready for our t-chart. In the middle of your t-chart is where we will choose our value, our starting value. We want to choose values that would cause the exponent to equal 0. In this case, our exponent is y, so to set it equal to 0, well, that would be 0. From here, we choose a few values before and after. Now we're ready to plug the values in. When we plug a 2 into the function, that gives us 3 squared, and 3 squared is 9. From here, go ahead and complete the t-chart. Hopefully your ordered pairs are 9, 2, 3, 1, 1, 0, 1/3, -1, 1/9, -2. From here, we're ready to graph, so take a moment to do your XY axis and plot these points. Hopefully your graph looks something similar to mine. Now remember, all graphs must indicate any asymptotes or intercepts. In this particular example, we do have a vertical asymptote at x equals 0, and our intercept is at 1, 0. Example 3, graph the function h of x equals log base 2 of the quantity x minus 2. Now, notice this notation. There's something inside the function. When something's inside the function, we think there may be a horizontal shift. In this case, I think it might shift to the right 2 units. So just keep that in mind whenever we get to the graphing part. All right, so looking at the function, we do want to rewrite it with a y. When we do that, it now becomes y equals log base 2 of the value x minus 2. Now again, when solving, we want to isolate log. Notice this says log of something, because it's in parentheses, that means it's log of that one complete item. So log is already isolated. So now we're ready to rewrite it as an exponent. The base 2 now becomes 2 raised to the y power equals x minus 2. From here, we need to solve for x. So in order to get x by itself, we must add 2 to both sides. And so now we have 2 raised to the power of y plus 2 equals x. Now that x is isolated, we're ready for our t-chart. Again, we always start in the middle and we choose the value that would cause the exponent to be 0. Since we have 2 raised to the power of y, the only value that'll make that 0 is 0. So choose a few values before 0 and after 0. Now we're ready to complete the t-chart. We plug in a 2 squared plus 2. Well, 2 squared is 4. 4 plus 2, well, that gives us 6. We now plug in a 1. 2 to the first power is 2, plus 2 gives us 4. Next, plug in a 0, so 2 to the 0 power, which is 1. 1 plus 2, well, that's 3. 2 to the negative first. Now remember, negative exponent means reciprocal, so 1/2 plus 2, well, that gives you 5/2. Next, 2 to the negative second power. Well, again, negative exponent means reciprocal, so 1/4 plus 2 gives you the fraction 9/4. Now that we've completed the t-chart, take a moment to graph and plot these points. Hopefully your graph looks something similar to mine. Now again, we must draw and label any asymptotes or intercepts. And in this case, we do have a vertical asymptote at x equals 2, and we have an intercept at the point 3, 0. Let's look at another example. Example 4, graph the function f of x equals log base 4 of x minus 3. Now, notice we have this minus 3 component of our function. Notice it's outside the function. It's not inside any parentheses or grouping symbols. So I think this might be a vertical shift, possibly down 3. So again, keep that in mind when we graph. So first, we want to rewrite this with the letter y, which gives us y equals log base 4 of x minus 3. From here, we want to isolate log. Notice I have log base 4 of x minus 3. Since the minus 3 is not part of the log, I need to isolate the log. So to undo subtracting 3, I must add 3. So y plus 3 equals log base 4 of x. Now that log is isolated, now we're ready to rewrite it as an exponent. The base, log base 4 of x, now becomes 4 raised to the power of y plus 3 equals x. Since x is already isolated, we're ready for our t-chart. Again, we start in the middle for our 0 value of the exponent. In this case, our exponent is y plus 3. Well, what value would make that equal to 0? Well, that would be a negative 3. So from here, we choose a few values before and after negative 3. Now, from here, this is your try it problem. Let's see how you did. Hopefully your completed t-chart is 16, negative 1, 4, negative 2, 1, negative 3, 1/4, negative 4, 1/16, negative 5. And as for your graph, hopefully it looks something like mine. And don't forget to draw and label your asymptotes And in this case, the x-intercept is not visible on the graph, so there's no need to label it.